All right, so I want to do some examples of calculating determinants. And so one of the things you read about in this section is about how to compute a determinant by what's called a cofactor expansion. And what it says is that, let's do a 3x3 example. It says, well, first we have to keep track of these signs, so we form this little checkerboard thing. And what it says we do is we can choose any row or any column. So I'm going to take the first row of this matrix. And what we do is we write out those numbers with their signs coming from the checkerboard. Okay? So I just looked at my checkerboard and that's what I got. And then what I do is next to each entry, so associated to this 3, I'm going to look at what happens if I delete the row and column coming from 3. And I'm just going to write that little, those numbers down here. And instead of using parentheses or braces, I'm going to use vertical bars, which means take determinant. Okay. Now I'm going to do the same thing under the 0. I'm going to remove that row and column, and I'm going to write what's left. So I have a 2, a 0, and a -1. And now I'm going to do the same with the 4. And I'm going to remove that, and I'm going to get 2, 3, 0, 5. And now I'm just going to calculate. So I'm just going to calculate, and I'm going to get 3 times, well, what is that determinant? Well, that's a 2x2 determinant. I'm just going to do the diagonals and subtract. So I'm going to get -13. Here I'm going to get 0 times something, doesn't matter. And then I'm going to get 4 times 10. And so at the end of the day, I'm going to get -39 plus 40, which is equal to 1. So this process is going to always return the determinant of the matrix. Right? And what's so cool about this is we can choose any row or column to do this with. So let's try another one. Let's see what happens if I choose the middle column and I work it out. Right? So let's do a different thing. So let's take those 3 numbers, 0, 3, and 5. And let's fill in the checkerboard. So I'm looking up here on my checkerboard now. I've got negative, positive, negative. So that's going to be negative, negative, positive, negative. And now I need to fill in what I get when I cross off these numbers. Now, of course, anytime we have a 0, we don't need it. So I'm just not going to worry about that. So let's see what happens if I take the 3 and I cross off its row and column. I get what's called the cofactor matrix, which has 3, 4, 0, -1. And if I do that with 5, I get 3, 4, 2, 2. Okay? And now if I work this out, well, that's 3 times -3. This determinant, let's see, it's 6 minus 8, that's -2. And I work that out, I'm going to get -9 plus 10. Once again, I got 1. So it is a true fact that no matter what row or what column you choose to expand, you will always get the same answer, and that number is the determinant. Okay? So this is a pretty cool feature, and let me show you how we might use that. So let's do a harder problem. Let's try to find the determinant of this 4x4 matrix. Right? And what I want us to imagine is doing that sort of expansion. Okay, we're going to need our pluses and minuses. So we're going to need plus, minus, plus, minus. It always just alternates. Okay. And what we're going to do is we can pick any row or any column we want. I could pick this row, and I could write those 4 numbers out, find the cofactors. I could choose this column. I wonder what would be the smartest column to choose, or the smartest row to choose. This row would be decent, because I've got 2 zeros. That will make life easy. But this column will make life easiest, because I've got only 1 non-zero number. So let's use that. And so what the determinant is going to be, it's going to be 2 I'm going to look at my sign matrix here, and I'm going to say, okay, that's going to be plus 2. And now I need to multiply by the cofactor matrix. So let's cross off, let's cross off this row and column containing that 2, and write down what we have left. So now I have 0, 3, negative 4, negative 5, negative 8, 3, 0, 5, negative 6. And you're probably looking at that and saying, oh my gosh, it's still complicated. I still have to compute a 3 by 3 determinant. Well, you're right. Let's just move over. And now that's fine. That's still a problem we can do. So let's think about it. We need to draw our little plus minuses. And now, again, I get the choice. I can choose any row. I could choose this row. I could choose this row. Or any column. And I think if you look at it, the first column kind of calls out to you. It's going to be a lot simpler. Right? So why don't I use that? So it's going to be 2 times. And now what goes inside of there? Well, I guess we're going to have a negative 5. And then we need to check our sign. Let's see, that 5 is in the second spot. So that actually gets another negative. So I'm going to make that a plus. And then I have to work out the cofactor. So let me work out the cofactor. So I'm going to cross that 5 out. And now I get 3, negative 4, 5, negative 6. And I keep going, keep going. And this calculation is now pretty easy. It's going to be 10 times that determinant. Let's see. That's going to be negative 18 minus negative 20. That is 10 times 2, which is 20. And so this whole process that we do with these cofactors really isn't that bad once you get used to it. Okay. So maybe I'll do one more just for some practice. Which one do we want to do? Let's try to do a big one. Let's try to do this one at the bottom because it's got some space. So I'm looking at that. I'm saying it's 5 by 5. That looks insane. But I see this row here is mostly zeros. And also this column here is mostly zeros. Let's try that column. Okay. So if I think about what my plus minuses are going to be, I can kind of just fill that in. It's going to be plus, minus, plus, minus, plus. So if I expand that out, I think I'm just going to get a plus 1 times the cofactor, which is going to be, let's see, if I cross this off and I cross this off, oh my golly, I get a big matrix, 6, 3, 2, 4, 9, 0, negative 4, 1, 2, 0, 0, 0, 4, 2, 3, 2. Now would be a good time to maybe pause the video and see if our answers match up at the end. But I'm just going to keep going through the same thing. I'm going to now choose to expand across this row because I see all those zeros. And I'm going to think about my signs. So my signs are going to be plus, minus, plus. It always starts with plus. So that's going to be a plus. So I'm going to get 1 times 2 times the determinant of the cofactor. So I'm now going to cross off this row and this column. I'm going to get 3, 0, 2, 2, negative 4, 3, 4, 1, 2. And now my luck has kind of ended. Because now I have to actually do a computation. I only have 1 0. Maybe I'll choose that column. So now I'm going to have 3, 0, and 2. And I'm just going to fill in my cofactors here. So 3 is going to have this cofactor down there. 0 we don't care about. And 2, let's see, that bottom one is going to have cofactor 2, 4, negative 4, 1. So at the end of the day, I get this, 3 times negative 11. And plus 2 times, let's see, that's 2 plus 16, that's going to be 18. And so I get 2 times, this is 36, this is 33, So at the end of the day, I get 6. So this process is, I think, fairly boring when we do it. I don't think it's hard. I just think it's a long process where we have to be careful. And if you want to see more examples, just let me know. There are also tons of videos online of people working these things out. So comment, subscribe.